Hello, my name is Ben Sigmund, and I'm a business development manager here at BUCHI. We are back today for the fourth installment of Supercritical Chats. If this is your first time listening, this is a technical series aimed at demystifying SFC and providing education on the impacts and unique differences of SFC compared to other chromatography techniques. Today's topic is achiral separations using SFC. Joining us again is Madison Reckel, our chromatography specialist, to help explain achiral separations on SFC.
Thanks, Ben. It's nice to be back for another episode, and for all of our viewers that were here our last couple times, yes, my last name has changed, but I am still the same person. I'm looking forward to discussing achiral separations today on the SFC. I think we gave chiral separations a lot of attention in the last episode, and I've been really looking forward to talking about the potential for achiral separations.
Great. Now, you've already covered a lot of information in previous chat installments regarding SFC technology, the environmental and economical impacts of switching from liquid chromatography to SFC. We'll link those in the video description, but would you mind sharing a brief recap?
Sure. So if you remember from our previous topics, we covered the faster processing times that are enabled thanks to the increase of interactions within the column, providing a more efficient separation combined with a much faster flow rate. The use of supercritical CO2 reduces the amount of solvent used and the waste generated, which saves time and money. Less solvent being consumed, less waste to dispose of, and less solvent to remove during concentration all make this more efficient and cost-effective. SFC can also utilize the same columns as prep HPLC, but thanks to the enhanced properties of supercritical CO2, like I said before, those separations are going to be more efficient. And that efficiency is what we're going to leverage for our achiral separations.
So, chirality seemed like a very niche region of organic molecules. As we move into today's topic, would you mind defining an achiral separation?
Absolutely. So an achiral separation is essentially a separation of anything but chiral molecules. So as you can imagine, that is a pretty broad scope. It can be anything from a reaction mixture to a complex natural product extraction. It covers a lot.
So, essentially, all compounds will fall into this class of molecules if they're not chiral. Achiral separations seem unavoidable.
I would say in most chemistry labs, achiral separations are absolutely unavoidable. They're even necessary prior to getting to, say, a chiral separations. Like most synthetic routes to a chiral or an achiral target requires several steps, and therefore will need some kind of achiral purification prior to that final step, whether it be a chiral separation or analysis for final shipping. They're unavoidable.
Got it. So most chemists are comfortable with flash and HPLC separation techniques. If those are achieving separation for achiral compounds, why would someone consider switching to SFC?
So it really comes down to time, cost, and efficiency. These achiral separations can sometimes take several passes on the flash and prep HPLC before you reach that desired purity. So if you're doing several passes, this takes time and more solvent, which in turn increases the overall cost of the purification. SFC is an attractive alternative that is both less costly on the solvent front and also will go much, much faster. So this is not only because the flow rate is faster, but like we said before, that efficiency of the separation increases. So essentially this means that it may only take one run versus multiple runs in order to isolate the compound of interest. It's kind of like going on a road trip and you're in a horse and buggy or a gas-powered car.
Okay, yeah, I can follow that analogy. And all of that sounds very promising. Some things that may be different, though, is if I'm approaching a novel achiral purification, how would I screen those conditions? I've gotten very comfortable with flash chromatography, loading just a little bit of material on a TLC plate, running it in different ratios of my AB solvents. Pretty easy to find some strong conditions.
Right. So I wouldn't say it's exactly the same. There's no TLC equivalent method for screening for SFC. But thankfully, the screening can be just as easy. It really comes down to running your sample through different analytical stationary phases to determine that best method.
So no more cutting, spotting, or elution chamber prep?
Correct. Plus, stationary phases play a really critical role in SFC method development. So doing your screening against multiple columns on an automated system is actually a lot more comprehensive than running TLC plates where you're just really limited to silica as a stationary phase.
That does sound fairly straightforward. Since achiral mixtures will result in varying elution behavior, the best conditions for purification will surely depend on the compound of interest. You mentioned screening various columns. Is this due to selectivity?
Yes, so selectivity is key when choosing an achiral column. Choosing a column that has the correct interactions with your compound of interest is inevitably going to produce the separation that you want.
Are there some staple columns that I should have in my toolkit?
Yeah, so usually for achiral separations, we work with polar stationary phases. 2 or 3 of these phases is usually sufficient for screening many conditions. I would say a few must-have columns in my book would be, your plain silica column, an ethyl pyridine functionalized silica, a diol, and possibly a polyethylenamine for your achiral separations. The nice thing about these columns is that they are silica with a covalently bonded identifier. So you're not really limited to your mobile phases or your mobile phase conditions like you are with our chiral columns that we referenced last episode. So these stationary phases are a little more robust. They're not as expensive, so you don't necessarily have to be as careful when you're designing a method in order to protect the actual column.
You're taking a few things in favor of that screening process in my book. Okay, so with those few stationary phases in my oven, adjusting the mobile phase starts to take focus. Acid and base modifiers are often used to enhance the resolution and separation in flash and prep HPLC work. Can I use similar mobile phase augmentations with SFC?
Yeah, so additives for SFC are usually weak bases. We're not using those acid modifiers really in SFC. And those weak bases are going to inhibit the silanol interaction with the silica. And SFC often likes to use neutral conditions. But if you are using a basic modifier, ammonia, ammonium bicarb, ammonium hydroxide is usually what we tend to like to use. And this is because these weak bases don't alter the column chemistry as much as, say, an acid would. It's also important to keep in mind silica does have a pH limit, so we like to stick with neutral conditions for that reason. Another great way to, enhance or change your mobile phase is to blend your modifier or switch to a different alcohol. There are a lot of different options here.
Okay, fantastic. So once we've screened the ideal column and best mobile phase conditions, what strategies are available to increase throughput?
So in general, there are 2 levers we can pull to increase that throughput. One is the column size and the other is stacked injections. Larger columns are going to allow larger sample loading per run, and stacked injections enable users to inject a new sample before the prior run is finished. Essentially, you're introducing sample on a time interval basis, so you're not running one complete method and then having to start another one. It's important to note that this stacked injection capability only works with isocratic conditions, but since it so drastically increases the throughput, it's worth investigating.
I can certainly see the utility of developing an isocratic gradient. That's very interesting. So I have been asking these questions because a project has been chewing up a lot of a customer's lab time. They've been isolating stevia side, the sweetening agent that has 0 calories. The extraction proves efficient, but their subsequent purification of the natural product proves quite tedious. After an hour spent extracting and concentrating the materials, they recover about 18% by weight crude material that's ready for purification, where they then start on a flash run, solid loading some of that extract with C-like, connected in line with an equilibrated amino functionalized column. Those later eluting fractions are concentrated to dryness before they dissolve them in about 1.5 ml of 1:1 water acetonitrile for their prep injection on another amino-functionalized 10 micron column. These isocratic gradients take 10 and 43 minutes respectively between flash and prep before considering the equilibration and concentration steps involved, which add an additional 35 minutes. Is there a more efficient approach to purifying this natural product in less than 90 minutes?
I would say there is. That same product, which I love stevia, I put it in my coffee every morning. That same product takes only 31 minutes on the SFC. Not to mention collected roughly an eighth to a quarter less solvent, so the dry down process is actually also expedited for analysis. Additionally, that stationary phase that you use in SFC is just silica, so you're not messing around with any functionalized amino columns. So it's I would say a little bit more superior.
Yeah, and it sounds like a cheaper stationary phase to start with. That's very impressive. Admittedly, I do have some reservations. From previous episodes, you were talking about how some of the models of SFC only have 8 fractions available, and their extract has over 30 fractions. How would this work on SFC?
So while any of the SFC units could be run for chiral or achiral separations, BUCHI does offer the prep systems with a configuration that includes a fraction collection bed and an auto sampler. So these configurations are great for collecting many fractions. So yes, of course, you will have a separation that has more than 8 fractions, and we have a configuration to accommodate that. With the fraction collection bed, the fraction arm has one single gas liquid separator as opposed to the 8 independent ones. But with that single gas liquid separator, there is an add-on or makeup pump that provides adequate solvent for collection, and it also reduces the chance of cross-contamination when you're using that continuous gas liquid separator.
That's always an upside when you can ensure you have some clean fractions. Are there any other benefits I should know about that come with the SFC?
Yeah, so well, generally speaking, the mobile phase conditions for SFC are oftentimes milder, which we touched upon earlier. So, we're working with neutral conditions, which means that you might have some really delicate natural products or even synthetically made molecules that are actually going to be a lot more protected in SFC conditions versus LC conditions.
Well, protection of my compounds is great, but what about detection? I like to use the ELSD on my LC instrumentation. Is that still an available option on SFC?
Absolutely. So I am one to say that it's very important to have multiple forms of detection when dealing with mixtures where you might not know all the analytes. So UV is obviously the standard for chromatography instruments, and the SFC is no different. It allows you to monitor up to 8 wavelengths at one time. And for you, Ben, we can put that external ELSD on, and you can monitor all your non-chromophores that you may or may not know are in your solution. What's really cool, though, is that this instrument is also compatible with a mass spectrometer.
Ooh. So not only could I separate my compounds and get an idea of their mass, I could actually understand what they are because of that information.
Exactly. Mass spec is a great tool when it comes to structure elucidation. And if you happen to know the mass of your analyte that you're looking for, you can collect based on that mass.
Neat. Since achiral separations could require a wide variety of workflows, would you be willing to share some best practices for a few topics?
I will do my best. Is there anything you had in mind?
Yeah, so are there any strategies for injecting hydrophilic compounds since water doesn't necessarily mix well with those normal phase conditions which supercritical CO2 emulates?
Yeah, I'm glad you brought that up, and it's a totally valid concern, especially since we were just talking about a natural product, and natural products are often a little bit more hydrophilic than other molecules. But luckily, many practicing purification scientists have actually found a workaround to this. Injecting in 100% water, like you said, you're going to have miscibility issues. It's not going to work. But if you blend water with an alcohol, usually it only takes about 5% water in an alcohol solution. This helps keep those hydrophilic compounds soluble during both injection and throughout the column. I would say the one accommodation you have to make when doing these blends is that you need to raise your column up in temperature a bit. So we're talking about going from maybe 40C to 50C. But in general, this has worked quite well and has been a great workaround for people working with those more hydrophilic compounds.
Wonderful. What about those cases where even water may not be sufficient for dissolving my starting material?
So we talked about the blends, but if the blend is not going to suffice for your molecule, because we're using these covalently bonded silica columns, you actually have more accessibility for your injection solvents. So that would include DMSO, DMA, DMF. Those are all options available to you. I would just caution if you're going to use those as your injection solvent and you are also using MS detection, there might be some interference and some undesirable effects on the MS side.
That's good to know. I'll keep an eye out for that. One more for you. So, if running some metal catalyzed chemistries, how tolerant is an SFC system and those associated columns to those metal contaminants? Should we be taking some extreme caution before injection?
Extreme caution or just good practice, good housekeeping?
I guess best practices is what I mean.
So whether we're running SFC or prep HPLC, keep in mind these columns that we're using are the same value and the same quality, meaning they're very small particle size. So we really don't want any solid particulates entering into the system. So as always, it's important to make sure that your samples are well filtered and completely soluble. This protects the column and the system itself. So it's good practice to do regardless of what chromatography you're running.
Sage advice. I appreciate that, Maddie. It also sounds like a guard column is still a fit in this setup, actually.
Yes, absolutely. Guard columns have a place everywhere.
It seems like SFC will be an instrumental asset in efficiently separating various compounds for faster separation times with less solvent to remove later. I'm going to start spreading the excitement about SFC right now.
Well, I think there's plenty to be excited about and enough to go around.
It was great talking to you today about SFC. Thank you for joining this section and all prior sessions. If our listeners want any more information about SFC, contact your favorite BUCHI team member and we'll be happy to discuss the technology and configuration, or at least get you in contact with our chromatography expert, Maddie.
It was great to share more SFC with you today and clear any doubts about its approachability. For our listeners, we may be done with chats for the year, but that doesn't mean the conversation stops. Like Ben said, we are always happy to chat with our customers. Thank you, Ben, for joining me for the last chat of the year, and I'm sure I'll see you here in the lab very soon.
Oh, I'm on my way. Thank you, Maddie.